October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. As 1961 concludes, the Snowy Mountains Hydroelectric Authority and its Commissioner, William Hudson, shift their efforts towards progress within the elements of the Lower Snowy Scheme, starting with the Snowy Murray development, where previously only the Guthaga system had been built to gain quick progress and show outside parties that results were being achieved. To date, just under 12 years has passed, and roughly 660 megawatts of generation capacity has now been made available to New South Wales and Canberra via the scheme. Proposals for the Snowy Murray development begin to get actioned, but with alterations to the plans of the original scheme, following information around geological investigations at the former Gehi Dam site indicating poor ground conditions. This would unfortunately result in a pumping station being required to transfer water from Lake Jindabyne into the Snowy Murray development. Additionally, a further trans-mountain tunnel connecting the Snowy Murray and the Snowy Timit developments would be needed, an element which had previously not been planned for. Completing these works over the next 8 years between 1962 and 1969 is covered in the 2 episodes ahead, where the generation capacity of the overall system will grow further to 2,160 megawatts by 1969, or roughly 58% of the total scheme capacity of approximately 3,740 megawatts as of September 1973. The original plans, as illustrated, had the 2 schemes separate from one another, and so progress had occurred with the Snowy Timit development, leaving the Snowy Murray development to be further detailed and explored. The need for a pumping station would prevent practical transfers of the volume of water needed for the Snowy Murray development, and so a new link to Lake Yucumbene was needed to provide and enable gravity transfers to take place, as well as store seasonal runoff from the Snowy River catchment. Lake Jindabyne would still proceed as per the original plans to provide storage, and much like Lake Yucumbene flooding at Amenabe would result in the flooding of the former township of Jindabyne, sited lower in the valley alongside the Snowy River. Now, the key reason water from Lake Jindabyne is pumped is due to early investigations around the Gehi Dam site, concluding that conditions were unsuitable and that it would need to be relocated roughly 4 to 5 kilometres upstream as part of a high-level diversion, shown here in yellow, with the original alignment shown in red. There appeared to be one rather large problem, however, as now it is 1961, and Lake Yucumbene has been filling gradually, meaning the ability to open up a new portal heading for this new and unplanned trans-mountain tunnel would present some challenges. It seems, however, the engineering team came up with an innovative solution where, much like the Tollbar portal feeding the Snowy Timit system, the former outlet portal below Lake Yucumbene would be repurposed to serve as both an inlet and outlet for this system. And so, the first new component outside of the Guthaga system within the Snowy Murray scheme would be the Yucumbene Snowy Tunnel, which, although likely a frustrating change of plans, did actually result in more water being able to be stored within Lake Yucumbene sooner than anticipated, mainly due with its link to Island Bend. Island Bend, like Junction Shaft in the Snowy Timit development, would serve as a critical junction point within this southern development. Commenced in 1962, this dam would take 4 years to construct, alongside its drop shaft structure, serving as the outlet portal, and being completed in 1965 alongside the Yukonbean Snowy Tunnel and Snowy Gehi Tunnel shortly afterwards. Located below the Guthicka Power Station, it would impound the water from the upper Snowy River and enable it to be transferred to Gehi Reservoir for energy production through the Murray Power Stations, or transferred to Lake Yukonbean for long-term storage and diversion back towards Gehi when demand requires it. Once water enters the outlet shaft from Island Bend, numerous control structures enable the various diversion and flow regimes to take place. Seen here are the outlets to the Island Bend, Yukonbean, and Snowy Gehi control structures in cross-section. Using the Island Bend and Snowy Gehi structures would let water flow towards Gehi Reservoir. Closing the Snowy Gehi structure and opening the Yukonbean structure permits reverse flow through the Yukonbean Snowy Tunnel back towards Lake Yukonbean. The Snowy Gehi Tunnel, approximately 14.4 kilometres in length and being less than 14% lined, connects the Island Bend development to Gehi Reservoir and its inlet-outlet structure. This particular structure, I feel, is the most complex out of all built within the Snowy Hydro scheme, as it integrates both inlet and outlet functions as well as their control gates within the same structure, and incorporates a small bypass regulation gate. Construction of Gehi Dam, its diversion outlet, and the inlet-outlet structure noted before would happen between 1962 and 1966, and once ready for use, permit the closure and sealing of the diversion tunnel beneath Gehi Dam, as can be seen here. With these key elements of the lower Snowy development underway, and in parallel to these works was the beginnings of the Murray 1 power station also taking place. Murray 1 power station, seen here, would receive waters from Gehi Reservoir via the Murray 1 pressure tunnel and pressure pipelines, dropping several hundred metres down the mountain range once daylighting from below ground. Within the power station itself are 10 turbines and generators, producing some 950 megawatts of generating capacity, the largest within the scheme up to this point in its construction history. At this point within the scheme's development, Murray 2, its power station, tunnels, pipelines, and dam were not yet awarded and under construction, which meant water leaving Murray 1 flowed unrestrained into the Cancoban Back Creek towards the pondage under construction. This meant a retarding structure, or weir, would be needed to maintain adequate back pressure on the power station turbines, and though not easily visible, its outline is only just perceivable via aerial imagery. This image, taken from the annual report from Snowy Hydro, better shows the weir and it functioning during this early stage, but typically this structure would be inundated once Murray 2 was commissioned and put to use. With numerous Snowy Murray components now ready for use, water could be diverted from the Snowy catchment via Island Bend, fed by Guthicka and its power station. From Island Bend, it enters the Trans-Mountain Tunnel system, sending water through the Crate Dividing Range towards Gehi Reservoir, which would still receive its own inflows from the Gehi River. From here, it enters a further pressure tunnel system, daylighting at the Murray 1 development, before flowing unregulated down the Cancoban Back Creek towards Cancoban Pondage, still under construction, which provides a great segue into the last element constructed under this initial stage of the wider Snowy Murray scheme, the Cancoban Pondage. Cancoban Pondage and its dam are the final point where water collects before leaving the Snowy Murray scheme and flowing towards the Murray River and Lake Hume. The dam itself is a basic earth-fill dam, less than 20 metres in height, but roughly 1 kilometre in length. Ingeniously, the engineers designing the scheme sought to utilise fill for Cancoban Dam from the Tullwater Channel being excavated for Murray 2's power station, likely providing cost savings in the process between the two projects. The dam itself has no power station, unlike blowering in the Snowy Tumut development, instead serving purely as a regulation structure via 2 large control radial gates and a third smaller one, enabling the release of water into the Swampy Plain River, which later joins the Murray downstream. This structure would be commissioned in 1966 and result in the first stage of the lower Snowy Murray development being brought online and further contribute an additional 950 megawatts of energy across Victoria, New South Wales, and Canberra. It would also increase water used for irrigation via its ability to shift runoff and snowmelt across the Great Dividing Range from the Snowy River catchment. So, we're now well past 1949. In fact, we're some 15 or so years in, amongst the mid to late 1960s. The Upper Tumut development is complete and operating, gradually repaying its investment back to the Australian public via the energy being supplied. We're also in a totally new space now, with the waters from the Snowy and Upper Tumut rivers being captured, regulated, and with respect to the Snowy River, diverted inland, away from its natural course towards Gippsland, Victoria, instead towards the Murray River, its irrigation districts, and mouth in South Australia. From an energy generation perspective, we're only just a little bit short of the halfway point of the scheme's total capacity of 3,740 megawatts, with roughly 43%, or 1,610 megawatts, now available, with Murray 1 being brought online and supplying a growing nation from an industrial and commercial perspective. The next episode looks to the remainder of the Snowy Murray development, which will occur over the next 5 years, between 1964 and ending in 1969, having already partially commenced through Murray 1's construction, and now focusing on the remaining elements of the Murray 2 power station, the Jindabyne Dam, and the Jindabyne pumping station, along with the pressure tunnels linking them, needing completion and commissioning. Thank you for watching, and please look out for the next episode in this series, exploring and celebrating the Snowy Scheme and its 75th anniversary.